Hello and welcome to the next video in the AD400 lecture series. Today we're going to be taking a look at project management basics. So we'll actually start diving into concepts around project management and some of the basics therein. So for our management spectrum, there is defined to be 4 P's, the 4 P's of management. They are people, which is the most important element of a successful project. It can also be the most complex. Product, which is your software to be built. Process, which is the set of framework activities or software engineering tasks that need to be completed. And the project, so all the work that's required to make the product a reality. Okay, so we talked about stakeholders before. I've used the word stakeholders, and a lot of you probably know pretty much what stakeholders are at this point, but let's go over more formal definitions. So stakeholders are going to be anybody that's involved in the project that has some sort of value that they're deriving from it or putting into it. So some examples of these would be senior managers who define the business issues and have significant influence on the project or technical managers who have to plan, motivate, organize, control the practitioners. You have the practitioners who are actually delivering the technical skills that are necessary for engineering the project. Customers, they specify the requirements for the software and make sure that the requirements are being met by meeting with the customers. And then the end users, which are going to be interacting with the software once it is released for production use. So these are all the stakeholders that are involved in the project. These are the people who are deriving value or have some investment in the project. And then we have our team leaders. So Cozy has exemplary practices that he lines out for technology leaders. First one is model the way. So we want our leaders to be practicing what they preach. So they demonstrate a commitment to team and project by shared sacrifice. I don't know if I've ever shared this with you before, but the difference between a boss and a leader is that a leader will join in whatever team he's leading and the work that they're doing and help them to accomplish the goals. Whereas a boss will give instruction and then go back to their office and not participate. So a leader models the way. They demonstrate commitment to the team and have shared sacrifice. Team leaders also inspire and share their vision. So they motivate team leaders to tie their personal aspirations to team goals, involve stakeholders early. So, if you have a good team leader, you have somebody who sits down and says, so what is it that you're trying to accomplish? What's your goals? And maybe somebody says, yeah, I really like to move into a senior software developer position by progressing my DevOps skills. And the team leader might say, okay, well, let's put you on this particular aspect of the project and move you in that direction. You're going to have a lot more loyalty with your team if you're actually working with them to not only achieve your goals or the project's goals, but to achieve their own goals. Okay, so the next one is you want your team leaders to challenge the process. So they're going to encourage their team members to experiment, take risks in helping them, generate frequent small successes while learning from their failures, enabling others to act, increase the team's sense of competence through shared decision making and goal setting, and finally encourage the heart, building community, team spirit, celebrating goals and victories. Really, if you want to have a cohesive team that's going to be working together to create an amazing product, you want loyalty, you want camaraderie, you want people to feel like there's a community, right? So they can be vulnerable, trust each other, grow and learn. Okay, so now we're going to talk about some team coordination, communication issues. Usually there's, if it's a large-scale project, it can have many lots of complexity, confusion, some difficulty in coordinating team members. Also, there may be uncertainty, which is actually very common, results in a stream of changes that ratchets the project's team. So if there's lots of changes and the team is not really sure what's going on, are we doing that feature? Are we not doing that feature? Who's making the decision on this? That can cause coordination and communication issues, and also interoperability. So new software must communicate with existing software and conform to the constraints. This is more of a issue with the actual tech. So there needs to be a series plan in place to ensure that compatibility exists with the software that's being used. So we can have formal or informal communication. Both are important. Formal communication is going to be your writing, structured meetings, and other non-interactive, impersonal communication channels. Whereas informal is going to be more personal, allow the team members to interact on a one-to-one basis or with each other on a daily basis, share ideas ad hoc, ask for problems as arise. It's important to have this informal communication as well, because this gives the team an opportunity to develop that sense of community, like we had talked about, sense of vulnerability, so that they can share where their weaknesses are and grow and learn. So it can't all just be formal communication. Okay. So software scope. I've talked about scope before, but this is just a little bit more information. Context. So understanding the context of the software is crucial to understanding that it aligns with a larger system, product, or business objectives. So this involves identifying how software fits into the overall architecture, ecosystem, or workflow of the organization. May also involve integrating with existing systems or platforms, adhering to industry standards, and considering any constraints imposed by the overall context. So for example, the software might need to interface with other applications, share data with external systems, stuff like that. So these questions will help you to resolve what the scope is around, context is around this scope. Next, we have information objectives. So what customer visible data objects are being produced? So clearly defining the information objectives helps identify the data requirements for the software, which involves specifying what customer visible data objects will be produced as output from the software, which could be reports, analytics, visualizations, things like that. Additionally, it involves identifying the data objects required as input to perform the software functions effectively. And then lastly, we have function performance. So understanding the primary functions of the software is absolutely essential to design and appropriate feature capabilities. So this involves defining what tasks or operations the software will perform to transform input data into output. So for instance, if the software is an e-commerce platform, its functions could include product catalog, management, order processing, payment handling, that sort of thing. Performance characteristics should also be considered with scope. They may involve specifying response time, throughput, scalability, resource allocation. As an example, software might need to respond to user actions within a certain time frame or handle a specific number of concurrent users. All right, so one of the things we want to do is, once we've got a high-level version of the problem, we want to decompose it or partition it. Once our scope is defined, we decompose it into its constituent functions, or it can be decomposed into user-visible data objects or into a set of problem classes. And we saw some of this before when we went through our use cases. We talked about our personas and all that. So understanding, being able to develop your requirements and then turn them into use cases is important. This decomposition is going to continue until all functions or problem classes have been defined. So your team decides which process model that they want to use that's most important. They have to consider the customers, people who are going to do the work, characteristics of the product itself, as well as the environment, the technical environment that's being operated in. So once they've considered all these, they select a process model, develop a plan. Once it's established, then they start decomposing it into the use cases. it's interesting in this class, in this particular topics, because we've talked about this a lot. So now I feel like a lot of it's just being formalized. Okay, so this fancy looking matrix right here is basically for a fitness app, and what we see here is that each major product, function, or user story is listed in the left-hand column, and framework activities are listed in the top row, and software engineering tasks would be entered in the following row, right? So these would be the different software engineering tasks that have to be accomplished within each one of these framework activities. And the job of the project manager is to estimate the resource requirements for each matrix cell, start and end dates for the tasks associated with each cell, and work products to be produced as a consequence of this task. So this, this is kind of like a generalized form of creating a Kanban board or some sort of visualization tool to map out scheduling. A Gantt chart would be another example. And we're going to take a look at some of those in class when we go through project planning and tracking. Okay, so what makes a project successful? So here are some examples. We want clear and easily understood, well-understood requirements that's been accepted by all the stakeholders. So everybody that's involved is on board and they understand what is to be expected. Active, continuous participation of the users through the development process. So the people who are actually going to be using the product are giving regular feedback through that iterative type of process. We want a project manager who's got excellent leadership skills and is able to communicate and share the project vision with the team. We need to have a very well thought out plan and schedule developed with stakeholder participation. And then we also need team members who are skilled and engaged, as well as we want them to have compatible personalities that work well together in a collaborative environment, realistic schedules, budget estimates. We need to be very rational and aware of what can be done and what can't be done. This is where struggle with planning fallacy comes into play, where it's easy to underestimate the amount of work that's going to be required, and that causes this feature scope bloat that makes the product get bigger and bigger. We want to make sure the customer's needs are understood and satisfied. We want the team members to have a high degree of job satisfaction. They're going to work better if they do, so finding out what brings that to the forefront. And then finally, we need to have a working product that is giving us our desired scope and quality. All right, so I don't know if any of you have heard of this. This is the W5HH Principle. So it stands for the 5 W questions and then the 2 H questions, such as, why is the system being developed, right? Why are we making the system? Who is it for? What's the point? What will be done? Okay, so we have to outline our processes. We have to outline our task sets. When will it be accomplished? Now we're doing scheduling, figuring out what can be done in the reasonable amount of time what can be done. Who is responsible, right? This is important. Who is responsible if the project fails? Who is responsible if it succeeds? Who is responsible for what different parts? Where are they organizationally located? Where are they organizations? So this is understanding how the organization of the project is as it exists and where things can be found. How will the job be done technically and managerially? So that's a process, question of processes and being laid out. And then how much of each resource will be needed. So identifying and estimating accurately how many people, software, tools, and database, for example, will be needed. And that, a lot of that, it comes with just time and experience and understanding and being able to estimate properly. Finally, let's take a look at some of these critical practices for project management. We need to have some sort of formal risk management to proactively identify, analyze, and manage risks throughout the project life cycle. We're going to look at a whole chapter on project management later. We need there needs to be an empirical cost and schedule estimation where we use historical data and iterative techniques to make realistic cost and schedule estimates based on experience and feedback. This is what we're going to be doing in the next chapter on project tracking and scheduling. Metrics-based project management, utilizing objective measurements and KPIs. KPIs are key performance indicators to monitor progress, track performance, and guide decision-making. You all, I'm a huge data file. I love using data for everything, and I feel like, especially in software development, having certain KPIs that are monitoring performance and decision-making is very important. Earned value tracking, where we measure product performance by comparing the value of the completed work against the planned value to assess health and make adjustments. Defect tracking against quality targets. So we need to make sure we're aware of the defects that are happening and find them, monitor for them, compare them against predefined quality targets to ensure we have high quality software delivery. Remember, high quality software is one of the most important aspects of software development. And finally, people aware project management. We want to foster a collaborative and positive work environment, promoting effective communication, nurture individual skills and growth to ensure we have team productivity and satisfaction. And a lot of that comes with understanding how people work and communicating with them in an informal way to understand what their goals are and what their needs are as well. So that's just the basics for our project management class, and I'll see you in the next recording.